So we are in chapter 11. Okay, so chapter 11 is talking about chi-square and also ANOVA test. Okay. Um, so this chapter present material on three more hypothesis tests. One is used to determine significant relationship between two qualitative variables. The second is to determine if the sample data has particular distribution. Okay. And the last is to use to determine the significant relationships between means of three or more samples. Okay. So the first one is section 11.1 chi-square test for independent. Okay. Remember what is the qualitative data? Qualitative data is where you collect data on individual that are categories or name. Right? So in this example, it's talking about the relationship between breastfeeding and causing autism. Okay. Uh, yeah, historically, the test is we call it a independent. I mean, cascade test for independent, but actually, this test is for dependent. Okay, so dependent what you mean is we need to test whether or not there is a correlation between two categorical variable. Right? Okay. So this is the step how to do the hypothesis test for chi-square test. Okay. First is you need to state the null and the alternative hypothesis. And as usual, you need to also to decide the level of significance, right? Okay. And the second step is you need to state and check the assumptions for the hypothesis test. Okay. So first is a random sample taken. So the sample was random taken. I mean, the sample is taken randomly. Okay. So the second one is expected frequency for each cell are greater than or equal to 5 expected frequency or E will be calculated later, right? Okay. And this assumption means E greater than 5. Okay. So that's the second step. The third step is find the test statistic and the p-value. Okay. So to find the test statistics in for superless set, okay. First, data is collected and counted, okay, and then it is organized into a table. In a table, its entry is called cell. Okay, these values are known as the observed frequency, which the symbol for an observed frequency is O. Right? Okay, each table is made up of rows and columns. Then each row is total to give row total, and also each column is total to give a column total. Okay. So this is the way to calculate the. Remember, for you're looking for what is the probability of A and B is equal to the probability of A times the probability of B, right? With the assumption that A and B are independent. Okay. But remember, if B dependent on A, so B will be like the probability of B given that A occurs, something like that. Right? Okay. So this is how to calculate the expected frequency. So calculate the expected frequency for cell A and B is equal to like this. This is the symbol expected frequency of A and B. Okay. So it is multiply. So in this case, in this case, E is equal to N, the sample size, right? And this one is like the so the expected frequency of cell NB is equal to N time the row total divided by N and time the column total divided by N. So it is equal to the row total time the column total divided by N. Okay. So yeah, so you need to find what is the expected frequency, and the table is the observed frequency, right? Okay. So to find the chi-square or the test statistics, you need to use this symbol. Okay. So like uh, the difference between the cell on the observed cell and the expected cell frequency, right? Square it and then divide by E. And so the distribution of the chi-square is like this. Okay. So the smaller the degree of freedom, the 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 curve will go like this. Okay, but the higher the degree of freedom, make it like look like a normal distribution, right? Okay. And this is the way to find out what is the p-value. Okay. The p-value is using this. This is one using calculator. This one using R, and this is the way to find the degree of freedom. Okay. So the number of rows subtract by one time the number of columns subtract by one. Right? Okay. And as before, like the conclusion, for the p-value less than alpha, we reject the S naught. Okay. If the p-value greater than alpha, we fail to reject. Okay. And the interpretation the same as before. Like the conclusion for this is either have enough evidence to show that it's true, or you don't have enough evidence to show that this is true. Right? Okay. So depend on this one, right? Reject or fail to reject. Okay. Fail to reject, the conclusion will be uh, have enough evidence to show that it's true. The its alternative is true, right? If fail to reject, that means we do not have enough evidence to show that its alternative is true. Okay. So this is the example. So this is known. This table is known, right? So this we call it as observed table, and we need to find what is the what do you call it the expected frequency table. Okay, using this formula. Okay. Yeah, in Excel I will give you the template to calculate all of this. Okay. Uh, yeah, maybe you can go to the MyOpenMath, and also you need to open the Excel, right? Okay. Okay, I go to the Excel for chapter 11, this one. Okay. Let me put in now download and save. Now let me open in Google Spreadsheet. Okay. So go to here, open, and then you need to upload it. Right? Okay. Um, should be in the download. Click this, open. Okay, so for number one, Okay, I think you need to go to the problem, right? Okay, for chapter 11. So this is will be so this is the last chapter in the MyOpenMath. Okay, and after this chapter, you need to take unit 4 exam. Okay, see here, down here. Okay, let me open this, and this is the first problem. Okay, so we know the observed frequency. Right? Now we need to find what is the expected frequency. Okay. Uh, so in Excel, we need to do is like this. Okay. So this is the expected observed frequency on the left side here. Then how to find the uh, this is the observed frequency. How to find the expected frequency? Remember, the expected frequency is uh, yeah. I'm referring here to page 375, right? You can see here. Yeah, you need to go back here. Oh, okay, hold on. It need to be 395, right? Let's see. Yeah, I think this one should be 395, not 375. Okay. I think I mistyped this one. So the expected frequency is n time the probability, right? Okay. So how many sample here? You have you have 1, 2, 3, 1, 2, 3, 4, 5, right? You can see here B12 is like the total number. I mean, yeah, the total number of sample. Right? So if you add the frequency of A, B, C up to E, so you got the sample size, which is 73. I mean 72. Okay. So so because the probability is the same and also the sample size is the same, the frequency will be the same. Okay. So you multiply, not multiply, actually you divide the sample size by 5 because actually you multiply the sample size with the probability, but the probability is 1/5, right? So it's the same thing as you say the number of sample divided by the number of by the number of uh, outcome, right? Which in this case is A B C D E, A B C D E, right? And you can see here this is if you're looking for the, you call it the square Pearson residual, or chi-square. Okay. I mean, sorry. This is correct. I think this one should be named as squared Pearson residual. Okay. So remember in the formula from 395. Okay. We use this formula, right? Okay. So this is the observed value for first cell, subtract with the expected value divided by, square it, and then divide by expected value, right? Okay. So you can see in this Excel, we did the same thing, right? So subtract, find the difference between the observed value and expected value. I mean, observed frequency and expected frequency, and then square it and then divide by the expected frequency. Right? So the expected frequency is C7, right? Okay. And the next one is for column 8 or for category B, and so on. Okay, and you can see if you add all of this, so you get the chi-square or the test statistic. Okay, yeah. So in your problem, you just simply replace this. You got all of the solution. Okay, so you just simply copy this. Yeah, since you cannot copy only one column here, so you can copy both column. Okay. Hopefully, will not copy this one. Okay. Let's see. Oops. Yeah. Okay. So we have a problem here. Okay. So apparently, I also copy the column on the right side. Okay. So I think you need to cancel. Okay. So I think we need to do manually. Okay. So like we need to put like one by one. Okay. So first is what? 25, 19, right? And then 23, 25, 23, 25, and the last one is 22, right? That's it. So automatically, already could put the formula here, so automatically everything is calculated. Okay. So the frequency, so this one will be 22.8. 22.8. You can copy this, paste it here, paste it here, paste it here, paste it here. Okay. And the square percent residual area will be, need to copy this one in one by one, right? Okay. Copy this, put it here, and copy this, put it here, and copy this, put it here, copy this, and paste it here, and this, and then paste it here. And the chi-square will be this guy down here, right? Okay. And paste it down here. Okay. So we can submit it, right? It didn't say, okay, say here is reported 2-3 decimal places, okay. Yeah, so you need to round up this to 3 decimal places. So that means is 0.088, right? Okay. Okay, so what is the next one?
Can you share the Google Sheet?
Oh, okay, sorry. Let me share it. Yeah, okay, try to copy it and use the copy for your own problem. Okay, don't use this one for your problem. Okay. Let's see here. So I will send to everyone. Okay. Yeah, so you need to copy and then save it in your own drive and use the copy to solve your problem. Okay, don't use this one. Okay. can use the copy to solve your own problem. Okay. 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 Let's continue with number 2, right? Yeah. So number 2 have to be careful here. Okay. You can see here there's row A, row B, because in this case you're comparing what is this row here representing? Uh, yeah, I think this one should be 395 also, right? I think I'm not mistaken. So number 2. So in this case is so number 2. You are conducting a multinomial hypothesis test. Okay, for the claim that the 4 category occur with the following frequencies. Okay, actually this is a probability. Yeah, so this one should be P, not rho. Okay. Yeah, I think this is P, right? Okay. So P A P A P P something like that. Okay. So this is the probability. Okay. So each category a probability here. Okay. So and what is the observed value here? The observed value here is 42, 24, 44, 29, right? So 42, 20, 42, 42, 24, sorry, 20, 42, 24, 44, 22, 42, 24, 44, 24, 44. And the B, 29, right? The D is 29. Okay, so you can see here the expected frequency is the same as, yeah, you need to change this one. Okay, so you need to change this to, because this one is like the probability for the category A. Okay, so 0 0.3, okay, the same, and then 0 0.2, the same, and then 0 0.3. Okay, so this one is 0 0.3, and
That one's 0.2.
0 0.2. Okay, thank you. Yeah, so you can see this is the observed frequency, and then looking for the expected frequency based on this formula, right? So the number of sample, which is the total frequency here, which is B11, right? Time with the B3. The B3 is the probability for A, right? And then the next one is multiplied by the probability of B, which is D3 here. Okay. And then C, and then the probability of C and the probability of B. You can see here. Okay. And using the same formula, right? The observed value subtract with the observed frequency subtract with the expected frequency, take the square, and then divide by the expected frequency, right? We got this one here. Okay. And then if you add all of these, you got the chi-square. So this one is, so you need to copy this one, 41.7. This one is 27.8. And then 41.7 again. And then 27.8. Okay, now put the square residual. The square residual will be this one. Put it here. Copy this one. Put it here. Copy this one. Put it here. And then copy this one. Put it here. Right. And now what is the chi-square value or the chi-square test statistics? This be this guy, right? And the number to be 3 decimal. So you can put like this, right? And you can submit it. Okay, so do you have any question? Yeah, you have to make sure you change this one also, okay? Okay, let's continue with number 3. Yeah, so this one is simply looking for what is the degree of freedom. Remember, the degree of freedom is the number of column subtract by 1. I mean the total of the total row subtract by 1 multiplied by the total column subtract by 1, right? So what do you get here? So that means there's 2 times 64, right? So the answer is 128. Yeah, so you know, number 3, right? Let me see. Let's see what different here. Oh, okay. This looks like we have different problem here. Yeah, again, this one should be 395. Okay. You can see here. So the degree of freedom is the number of column subtract by 1 multiplied by the number of rows subtract by 1, right? Okay. Okay, hold on here. Okay, so it's already have it here, three category. Okay, so you simply use subtract it, right? So the answer is 2 here. Yeah, the sample size is 65, okay, but the number of column is just 3. So, the degree of freedom is 2. Yeah, this one should be the same thing, right? So this is number 4. Okay, the observed, okay, again, this one is be 395. Okay. Yeah, so the observed ABCDE. Yeah. What do you have here? For number 4, 13, 16, 18. Yeah, 13, 16, 18, 7, 24. Right? 13, 16, 18.
It's 7 and then
Yeah,
24.
yeah, 7 and 24. 7 and 24. Yeah, so because you have 5 categories, so the probability for the system will be 1 over 5, right? Or the same thing as you're looking for the expected value or expected frequency. So you divide the sample size by 5. Right? Okay. And then the residual will be this one. Right? Okay. And the summation of this, you got the chi-square. Okay. Or that's statistics. Okay. Let me see. I want to make sure this is correct. Yeah, I think this is correct. So this should be 39395, right? Yeah, in this case, we only have the number of rows, okay, right? Because we only have a category. Okay. So the number of rows is subtract by 1 to get the dependent, the degree of freedom. Okay. Okay, let's see. So this will be 15.6, right? So let's see 15.6. Copy this, put it here, put it here. If only this is the same number, okay, so just need copy the same number, right? So now copy this, put it here, copy this, put it here, and then copy this, put it here, copy this. Oops, did I copy twice? No, right? Okay, yeah, so this is the last one, right? And then go to the chi-square. So the chi-square will be this one here. This chi-square will be this one here. And you need to put accurate to 3 decimal place, right? So accurate to 3 decimal place, so that means 10.077, right? And what is the degree of freedom here? 4, right? So you have 4 here, and the p-value will be, okay, yeah, you need to calculate. So you need to use this to find the p-value, right? Okay. So in this case, it's 2 tildes, I believe. Oh no, no, it's just simply using this command, okay? The chi distribution. Okay. So apparently I already put in the formula here. Okay, so this is the chi-square, which is this one or this one, okay? The same thing, right? Okay. So I pick the G6. So I pick here the G6, and then G9 is the degree of freedom, right? This one here. Okay. So the p-value will be this one. Need to put 4 decimal place, so you already have 4 decimal place here, and then compare the p-value with the alpha, right? The alpha is 0.05, 0.05 compared with 0.3, so this one is less than, okay? So less than alpha, okay? So because less than, so we reject, right? And because we reject, so the answer will be the sample data support the claim, right? Okay. Did we miss something here? No, right? It looks like we missed something here. Let's see. This one is here. Oh, the conclusion is not right. Okay. Let me see. Okay, in this case, it's greater than. Okay, I think this one will be the correct answer. Okay, sorry. So there is sufficient evidence to warrant rejection of the claim that 5 are okay. Yes, it's not correct. It's not correct if you say the data support the claim. Okay, so CDP, there is a sufficient evidence to warrant the rejection of the claim. Right? Okay. Okay, here we go. So the answer is either way, this one or the last one. Okay. If reject, so you pick this one. If fail to reject, you pick this one. Okay. So this one we have two categories. Okay. Female and male. Okay. And also we have option here. Okay. So yeah, this one is look like the one in the book, right? You want to see the two correlation, right? So number 5. Yeah, so Yeah, the same thing, right? So in the copy, let me see if you can copy all of this. Okay. Yeah, maybe you can copy all of this, right? So in this case, we can. I'll try to copy all of this column. Okay. Let's see here. If I can copy that. Oops, no. Look like I copy all of them, right? Let me see. Yeah, I can copy all. Okay. So yeah, automatically everything calculated, right? Okay. So how many individual are described? So the total of all of them, right? Okay, for 409, 4,900. Yeah. And P11 is how many female? Female will be P11. Right? How many female? Okay. And the percent of female among the correspondent. So you need multiply E8. E8 is, yeah, I think that's something, yeah. 50-50 chance, right? So yeah, this one should be 50-50 chance, 50%. Right? You can see this pointing to column, not column, row B, row. Yeah, so female, as you can see at the E8 divided by the E5, right? What is this E5? E5 is this one, right? Okay. Like the total of the individuals in the survey, right? Okay. So yeah, so and then the percent from the previous exercise part of, okay, yeah. Okay, so we got this already, right? Which is this one, and then put it here. And how many female are among respondents? So the total of female divided by by this one, right? So you got, and then multiply by 100%, right? So you got 54, okay, because you have to round up. Right? Okay, hold on. Sorry. Okay, sorry. I think I have to put this one first, right? Like how many female are among the respondents. So this one should be this one here. And this one should be 84, right? And Your percent from the previous exercise is part of. Okay, the percent of from the previous exercise is part of. So what do you think? I think it should be the marginal distribution of opinion about marriage, right? Okay, so it should be A. Okay, sorry. Yeah, because we're talking about male and female, so this is talking about the distribution of sex. Okay, second in here is female or male. Okay, so it should be the last one. Oh, the next 10 years. Okay, let's see. Let's see, what is the question for C? Oh, okay. Okay, so percent of female thoughts that were almost certain be married in the next 10 years. So how to calculate this? P10 divided by P11 times 100%. Right? So yeah, talking about what percent female thought that they were almost certain to be married for the next 10 years. So it's based on column, what is this here? Almost certain, right? So column B10, sorry, not column B10, row B10, okay, almost certain. So the answer would be B10 divided by the total of female, right? And then multiply by 100, okay? You got this number, okay? So if you round out this, so the answer will be 45% here. Okay? So the percent of female thought that they were almost certain to be married in the next 10 years. Okay, yeah, so this one is talking about the marginal difference of opinion about marriage, right? Oh, okay, so what is here? The percent of female thought that, yeah, the concern. Yeah, so the answer is the considerable distribution of opinion about marriage among women. Okay. So the first one. Yeah. Okay, so okay. Yeah, so number. Yeah, so this is the observed table, and this is you need to find what is the expected expected observation. Right? Okay. So you can go to Excel for number 6. So you need to find what is the total. Yeah, you can see also from. Yeah, I think this is around page. Okay, so I think I need to go to, let's see here. Oh, sorry. Yeah, so the same with this one, right? So this one should be, so the page should be, it start from page 395 up to 397, right? Yeah, 395 to 397, right? So this one should be 395 and 397, right? So total row times the total column divided by n. Okay. If looking for the expected frequency. Okay. So we need to change this to 48, 48, 11, and 13632. 13632. Okay. So and now you're looking for the expected observation, right? Okay, so you can see I already put the formula here. Okay, so the first category is category A, right? To find the affected frequency, you need to multiply the total of, yeah, you need to multiply D6 with B8. B8 is the total population for one, the first population, right? And then the second population. Okay, so looking for the expected value, multiply this row total times column total divided by n, right? So if looking for uh, expected value of A and population 1, right? So you need to multiply D6 with B8, right? So you can see row total multiplied by the column total and divide by, yeah, you can see here what the first for this one, right? So you multiply row total which is this one D6, right? with column total will be P8 and then divide by the sample, which is D8. I mean the total individual, which is D8, right? Okay, right here. Okay. Yeah, so the same thing for this one, you need to put the total of this times this divided by this, right? And for this one, the total of this multiplied by this divided by this, right? So you can see D7 time V8 divided by D8, right? And for this one, the same thing. This for expected observation for this one will be this one multiplied by this divided by the total, okay? Which is D8, okay? You got the expected value. Or the O. Okay, so you can type it back here. So you need, remember you have to change this one. Okay, so this one will be 48, and this is 136, and then 11, and then 32. Okay, here you go. Yeah, so don't forget to change this. Okay, and this will be, yeah, it should be page 395 to 397, right? Okay, so this one should be page 395 to 397. Okay, yeah, so you have to make sure there's this guy has to be the same with this guy. Okay, let me highlight it to make sure you don't have to change that one too. Okay, so everything already calculated. Okay, yeah, it's just, yeah, somehow I copy the expected value, but I didn't copy the observed value. Okay, so maybe I need to copy that one, so automatically will get it. Okay, let me put it here. So yeah, most of the system make mistake here. Okay, so let me just put it here. When you put it the number there, so automatically you will put it here, right? Okay. Oops. Oh, no. Hmm. Okay, I think maybe I need to do manually. Just like P6, right? Yeah, so this is B6, right? Okay. And then this guy will be C6. And this guy will be B7. And this guy will be C7. Right? Okay. So already like copy from here to here. Okay, so automatically if you change this one here, so automatically will change this one here. Okay, already put the formula there. Okay, okay. So now I think you need to copy this one, right? Copy this, put it here. 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 Okay. And put it here also, right? Okay, so submit. All right. Okay. Yeah, so think it's the same thing, right? 41, 41, 20. 41, 41, 20. And on here, 42, 26, 7. Seven, right? Okay. And yes, like automatically everything calculated, right? Yeah, apparently for this one already copy, okay? Already copy automatically from here. Okay. Yeah, okay. So now you need to copy this, put it here, and copy this, put it here, 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 copy this, put it here. And the classical will be this number here, right? Yeah, again, so this should be page, sorry, uh, 395 to 397. Okay, so, yep, the key of rhythm will be 2, right? And the p value will be this one. And you need to answer accurate to what is decimal place, right? Okay, let me see. Yeah, you need to round up to 4 decimal place. Okay. Okay, so the answer will be 0.0595, right? Okay. So for this case, you can see the p-value greater than alpha, right? So because greater than alpha, so that means it failed to reject, right? So there is no enough evidence to support the claim, right? Okay. Let me see if this is similar. Yeah, the same. So greater than alpha failed to reject. There is not enough evidence to warrant rejection. Okay. Okay. So that's a good answer, right? This is yeah. So for this one simply 7 subtract with 1 you got 6, and then 5 subtract with 1 you got 4. So 6 times 4 is 24, right? Okay. You can see here. So you have how many columns? 7, right? And then 5 rows. So the answer is 24. Okay. Okay, I think that's all right. We only have like 8 problems. Okay. So if you get all correct, so you should get like 80 of 80, right? Okay. So any questions so far?